Okay, I'm going to do this in shifts because it's just all very tedious and a lot of stuff to, write down, especially using this formula. Okay, whenever you come across this type of problem where you're given n and you're given p, okay, you are going to, there's actually two ways of doing it. I find this way to be easier. The other way to do it is, you have to deal with those functionals things or whatever they're called. And it kind of gets more tedious than this one. So I would just have this formula on hand. I'll show you how to use it on this video. Just be patient. Okay. So in this formula, we have P. Okay, you're given P 0.06 or 0.6. You're given N. That means the number of trials. Okay, that number of trials that you for this experiment is 12. R is simply x because you see how in the function where it says P of x equals R. So wherever we're dealing with R, it's just the x value within that set. And then finally, we have Q. If you're not given Q, it's easy to find, okay? So P plus Q has to equal 1. It's a rule. So if you're given P, you can find Q. So Q is going to be 0.4 because 0.6 and 0.4 add up to 1. So that's one of the things that you have to memorize and be like, oh, I remember P plus Q equals 1. So if I'm given P, I can find Q. If I'm given Q, I can find P. All right, now that that's out of the way. So the question number 11 says, well, what's the probability of getting fewer than 4? Well, that means 0, 1, 2, and 3. So therefore, we're going to take the probability of those 4 sets and add them up. Now, here's where it gets a little difficult. This is where we're going to use the formula and plug in the numbers. So I'll do the first one slowly, and then I'll speed up the process as I go along. Okay, x equals 0, therefore r is 0. In the formula, we start out with the combinations. If you look to the right in green, the reason why I like this formula is because I can just easily Google a combinations calculator, and when we have to calculate everything, okay, I use that online. That's why I choose this formula, because you can do that. All right, so the number of combinations is 12, and our first set r equals 0. Now, the number of possibilities of getting it, okay, so remember how Papal said, oh, it's a 50-50 chance of flipping a coin to get heads or tails. Well, I can't use that because it's a 50% possibility. Here is a possibility of 60%. So I'm not sure what experiment where you get 60%. So I'm just, hopefully you can keep up with me. So the chances of getting it, okay, the chances of getting it, the probability of getting it, 0 times. Well, that means the chances of not getting it, which is represented by the 0.4, that's what the Q stands for. The P stands for the possibility of getting it, and the Q stands for the possibility of not getting it. So you have to represent both sides. So the chances of not getting it means that there are 12 chances of not getting it. So if 0 represents it for getting it, then 12 represents it for not getting it, because there's 12 trials. Okay, let's try the next one. First, the combination. Well, there's 12 trials, and we want to see what it is for getting it one time, okay? So the possibility of getting it one time is represented like so. But the possibility of not getting it once means there's 11 chances of not getting it, okay? Because 11 plus 1 equals 12. Okay, let's try the next one. The combination. is so. And then the chances of getting it, we want 2 because it's in the combination. But then you also have to represent the chances of not getting it. 12 minus 2 is 10. Okay? All right, last one, last combo. So the chances of getting 3 means that there are 9 chances of not getting it. So this formula represents both the possibility of and the possibility of not. So hopefully I've done a good job in explaining that information and how to represent all this information in a formula. Okay, my next step is to actually multiply everything. So with this, you have 3 sections. You have the combination section, and then you have the first number that's raised to a power, and then another number raised to a power. So the first section in all of these, I'm going to use a combinations calculator. It's easy to Google it up. You know, it asks for 2 items. You plug in the numbers, and then you press enter, and it gives you the result. So like the first one, I Googled a combinations calculator. I typed in 12 for N, and then I typed in 0 for R, and it gave me the result of 1. So the combination for that is 1. Then I'm going to put 0.6 raised to the power of 0. Well, that equals 1. And then 0.4 raised to the power of 12 is actually going to give me a number written in scientific notation. So it's good rule of thumb to write down 2 or 3 numbers after the decimal whenever you have scientific notation, because it just makes your results more closer to the answer. And plus, look at your answer key. Okay, your answer key has like 4 digits to the right of the decimal. So that's why you want at least those amount of numbers in your work. Okay, so I'm going to just go ahead and work through this first one. Okay, so 1 times 1 is 1. So anything times 1 is 1. So that means this right here is going to be my answer. Now, I can leave it like that, okay, and type it in my calculator, but I have a good calculator. You, on the other hand, might not have a good calculator, so you might need to punch in all the zeros. So let me really quick refresh your memory on what scientific notation is, okay? So 1.678 times 10 to the negative 5th. That means I have to move this decimal to the left, okay, because it's a negative 5 times. So I'm going to, so there's 1, so that 1 takes up the first space. So that's count 1. And then 2, 3, 4, 5. There's the new place for my decimal. I fill in the empty spots for zeros. So that means 1.678 times 10 to the negative 5th power is actually this number written out in standard form. Okay? All right. I'm going to talk through the next one, and then I'm just going to, I'm just going to talk through the next one. So, again, using the combinations calculator, 12 combo 1, you get an actual result of 12. Okay, so then 0.6 to the first power, that's just going to be 0.6. 0.4 to the 11th power, it's going to be another scientific number, 194, and that's times 10 to the negative 5th. Okay, so now I'm actually going to leave this number right here in my calculator and then just multiply it by 0.6 and 12 while it's still in my calculator, so I don't have to retype everything. So let me do that really quick. All right, I'm going to get this as a result let's just go ahead and round that up, times 10 to the negative fourth. Okay, so this number is actually, I have to move the decimal over 4 times to the left. So that looks like this. 1, 2, 3, 4. Fill it in with zeros. So in standard form, this is the number that we're going to add down here. Alright, I'm going to go a little bit quicker. 12 combination 2, I think that was 66. 6 squared, 0.36, 0.4 to the 10th power, that's 1.049 times 10 to the negative fourth. Alright, times 0.36 times 66. So that's going to be, well, in my calculator, I got this as in standard form already, so that's good. Alright, and then the next one, combination for that is 220.6 to the third power is 2.216. 0.4 raised to the ninth power. That's going to be, I'm going to write it here, 2.621 times 10 to the negative fourth. Alright, 0.216 times 220. So that's going to be, alright, in order to answer question number 11, all I have to do now is add up those numbers at the bottom. I noticed as I was adding all those numbers at the bottom, I forgot a 0 down here. See what I mean? You got to be careful in solving all these. 1, 2, 3, 4, 1, 6, 7, 8. Okay. Okay, after adding everything up, so the probability of getting fewer than 4 is equal to 0.0152717. I went ahead and wrote them out, but if you look at number 11, question number 11, it looks like the correct choice is the first one. That was a lot.